it's not even about data, it's about knowledge, about your business, about your process. And without this knowledge, you cannot have any models which can give you, which can give you some kind of valuable insight, valuable hints and advices.
Hello and welcome to the Data Culture Podcast. I'm Carsten Bange, founder and CEO of Bark, and I'm joined today by Florian Bigelmaier because we will do a special series of jointly hosted podcasts that are leading up to the Data Festival. That will take place in June in Munich, and we will interview a few of the speakers at Data Festival upfront to already hear some of the stories and the experiences.
My name is Florian, and together with Carsten, we will talk today with Nikita Golovko. He's a portfolio architect for industrial AI at Siemens. And just as Data Festival, we will talk about the intersection of data and AI. We will talk about the data gap, how to make data AI ready. On the way to knowledge also, what does it mean to manage knowledge in the light of AI? And how can organizations and people within an organization work together on that challenge? Enjoy the episode.
Hello, Nikita.
Yeah, hi, hello, nice to meet you.
Yeah, very nice that you're in the podcast today, in the Data Culture Podcast. And today with me is also Florian. Florian, how are you?
Hi, doing good. Thanks for having me as a co-host today.
Yes, so I'm looking forward to this. And let's get started. Nikita, you were a guest and speaker in the last Data Festival online in October 25, and we were quite impressed what you accomplished at Siemens and what you're doing. So we thought it would be a great way to learn more from you in this podcast.
Yeah, thanks a lot for invitation. I always my pleasure.
Excellent.
Let's dive right away, I would say. So last time we talked about the gap, so to say, between large language models and also machine learning models on the one hand, and like the deterministic systems you're having in industries. And today, the first gap we in a way want to talk about is the data gap. So what would you say? Like, there is a lot of discussion out there around AI-ready data. Is there really a gap? Is our data ready for AI? What's your impression on that? Both for like the machine learning and the new large language model world, I would say.
Yeah, I would say the data gap is relevant not even for AI use cases. It's a big problem for, let's say, making any kind of decisions for a business. And considering the readiness of our data for being used in AI use cases, it's a rather tricky question because nowadays we see a lot of pilots, not successful pilots, and the main reason of having not success, from my perspective, it's a lack of data or bad data. That's why I would not say that we are not ready from the perspective of data for our use cases, but we should be more prepared. We should be more consciousness with our data, and every time when we would like to talk about bringing new cool AI model into production or building new prototype, we should first of all reflect on our data. Do we have do we even have a data infrastructure to build any kind of decision system, any kind of AI system? Do we ready to collect data? Are we doing this data collection in a continuous way? Do we have some kind of mechanism to work with data, to enrich this data, to first of all to reflect about readiness of our data infrastructure before we start to reflect whether it makes sense to use GenAI or any kind of AI at all?
Yeah, makes sense. You already mentioned some measures you could take on the infrastructure side and architecture side to get that gap, so to say, a bit closed. What we say is that like something looking a bit in the future that will stay, because like there are few voices out there that also say like large language models are moving so fast. You're always also having transformer models in the tabular data world. Is it still necessary to engineer data that hard and give so much effort into it? Or is that something that will vanish because models will make sense of data anyways?
No, definitely. In any case, you need to spend a lot of effort working with your data. because this trash in, trash out. In order to make a consciousness decision, in order to make a relevant decision for your business, you need to have enough knowledge. It's not even about data, it's about knowledge about your business, about your process. And without this knowledge, you cannot have any models which can give you, which can give you some kind of valuable insight, valuable hints and advices. So I don't believe that even having such kind of smart models as LLMs, so to say, smart models, will help us in, let's say, will fully replace this necessity of having data engineering, having building this data infrastructure. It can help to some extent in this journey, for instance, how to organize, how to prepare our data. It can be used as a tools to work with data, but it will not replace. We will not see in the future any models which will, let's say, by itself generate data, consume this data, and provide some kind of smart outputs. It's impossible.
You said that we need more knowledge. Are you referring to what is often now discussed as context and context engineering? So we need not only the data, but also more metadata and explanations around data?
Definitely, it's about context and also about knowledge. For instance, in industrial use cases, in industrial automation, let's say in my original sphere, we have a big knowledge gap. For instance, every company more or less identifies three data gaps: that we don't have enough data, data does not represent our use case, or data block somewhere. But majority of companies ignoring the fourth level of knowledge gap. For instance, when we have a lot of very experienced domain experts, which are not only in the context, but they also have some kind of historical knowledge about one or another process, how this aggregate behave, some kind of additional, not even knowledge, but meta knowledge, some kind of feelings, how it smells, how it sounds. And it's more about trying to collect all this knowledge, trying to digitalize all this knowledge from experts' heads to build some kind of knowledge infrastructures. First of all, data infrastructure, and on top of this knowledge infrastructure, then to use this knowledge, to use this digitalized knowledge in building some kind of advisors, helpers for the same operators to make more, to make better decisions, to make more consciousness decision. It's not even about context, because context, it's something you have at the moment. It's some kind of long-term context. It's not even a context. It's some kind of history of my knowledge. It's my background. It's more about background.
And when referring to like knowledge, we already have a lot of experience in the industry, right? Before the first AI winter, so to say, even people thought about how to model knowledge and so on. And it was always a huge task to get that done. Do you have any thoughts on that? How to make that maybe even more feasible today with like GenAI and so on? Are there any ideas you're having in terms of making that more efficient?
As I said, first of all, we need to reflect about building some kind of infrastructure, some kind of foundation for data. On top of this data, we can we can collect knowledge. How we can collect knowledge? Just give users access to this data, to enrich this data, maybe to check and to share their hypothesis, what this data can looks like, what this data can mean. And as addition, how we can use, for instance, generative AI. GenAI can be also used as a tool through which you can interview these experts, through which you can interact in some kind of chat or interaction mode with these experts, try to also get this knowledge, try to help them to maybe formulate their hypothesis, to be this partner in this interaction, sparring partner in this interaction to, hey, what do you think? What if? And try to enrich, try to build the whole picture of this knowledge with the help of this, for instance, GenAI.
That something you already do at Siemens, or is it more an idea?
Our department, let's say, more or less specialized on bringing AI models to the shop floor, classical AI. So our department is not doing this exercise, but I'm aware that some of our colleagues in Siemens are doing this from the perspective of not digital twin, but let's say human twin, operator twin. So they try, for instance, we have a super experienced operator who will be retired in a few months, and we need to build a helper or some kind of twin of this operator uh, who will help new colleagues to understand the process better, to understand some kind of limitations. I also read that that other big companies like Bosch and a lot of companies, it's some kind of obvious idea, also working on this topic. They're trying to use GenAI in this direction. Yeah.
So they're building up knowledge bases with more an interview style. So I think the key challenge is always to extract the implicit knowledge. Yeah. So what's in the heads of the people, and that's turned out to be a new way. Yeah. That now also not only a human expert can interview them, but also the GenAI system.
Exactly, and also maybe another challenge during this interview not to be biased, because every human being is biased, and we need to make some kind of filters on one hand to take this knowledge, but also to be aware that this knowledge can be biased, and to somehow distinguish what should we use and what should be, I don't know, double check with the help of another interviews. It's like a social interviews, but yeah, it's rather interesting sphere.
Yeah, absolutely. Let's maybe go a level deeper. So you mentioned, I think, these two main, let's call it layers. Yeah? You said we need a data foundation, and we have to put the knowledge on top in a way. Yeah, so to make the data usable, to help people also to make sense of the data, to take better decisions. What I would be interested in is now in more detail. So, what do you think are the key components? Yeah? If you think about like a data foundation, what would be the key components you would put in there, or you would see there? What makes such a foundation?
I would even propose some kind of a pyramid structure for this data foundation, for this data, let's say, architecture. So the first level, the first layer should be responsible for data collection mechanic. So it should consist of some kind of sensors or any kind of other data providers. So it's about raw data. The second layer should be about data transformation. To some extent, it's like some ETL or ELT. So how your data should be processed, I don't know, cleaned, and so on. The third level, how your data should be stored, but not only just put it as a mess to some kind of database. Your knowledge, your data should be stored in a way to be easily accessible, to have, let's say, quick access. It should be relevant to your business needs. And the fourth level, it's about knowledge. Knowledge, when we have some kind of ways for human beings to interact with this data, I don't know, some kind of UIs, some kind of modeling tools through which operators, users can consume this data. They can enrich this data with their hypothesis. So it's more about UA interaction, some kind of ways to agree or disagree with data, propose a hypothesis, check hypothesis. So it's, let's say, 4-level pyramid.
Especially in the last part, that's, I think, often new for people in the data domain, to now think about unstructured data, knowledge, and so on. So I think the other parts are pretty clear. So I think that's something we do for 20, 30 years, starting with data warehousing. Now this knowledge part, I'm super interested in that. What could you maybe also describe technically what's in there? Do you think about, let's say, graph databases, or is it what is that technically, just to grasp it better?
In any case, we are limited with some kind of technical implementation. So it can be a document-oriented database. It can be, for instance, if you would like to store knowledge and this connection between these knowledge pillars, it can be graph database. So I see this layer, this level of some kind of combination of databases which are able to store unstructured data to some extent. On another hand, to provide a quick interface to get this data, to observe this data, to visualize. For instance, we need some kind of smart interfaces to show these graph connections between knowledge pillars, between some kind of connected ideas, likely connected items. And it's difficult to say that we have a new, conceptually new type of database which will solve this problem technically. It's a combination because as upper we go on this pyramid, as more abstracted instruments and as more abstracted approaches we need to use. So we need to build new abstractions since we are talking about knowledge is also some kind of abstraction. So we need to work with abstractions, and we need to make our users aware of these abstractions, that we need to share the same terminology, the same abstractions with end users. So, hey, domain experts, you are living in the world of defects. We built for you some kind of abstraction on top of existing data. We name this abstraction defect. It means this and this. Please enrich this with your knowledge. Work with this as a part of your world and try to represent your picture of world with the help of these abstractions. So it's more about abstractions. It's difficult to say that you need to store this abstraction in specific database.
No, absolutely. So what you just described, I think the defects were a great example. You also call that a semantic layer as a interesting or key part?
Yes, definitely, it's a semantic layer because it should add some kind of, relations between type of defects, root causes of defects, consequences of defects. It's not about this. We are observing a defect in isolation. For sure, this defect some kind of place on a product item. It has some kind of reasons why this defect occurs. So it's definitely some kind of semantics, and that's why graph database can be one of good solutions, one of good ways how to represent the semantics, but not only graph database.
With every kind of architectural and information system change, there comes obviously also kind of organization change. What do you think, what is the biggest challenge, the biggest change that needs to happen in that sense to get to such a knowledge infrastructure on the organizational side?
Yeah, you're totally right that, architecture is mainly connected or highly connected with org structure. And every time when you build a new system, not even AI, you need to reflect what kind of team, what type, what kind of team do you need to implement this idea in practice. For instance, in order to have a successful AI projects, you need to have some kind of multi-domain team. So, for instance, your team should contain domain experts, data scientists, engineers, MLOps, DevOps. So it means that when you want to build something new, you need to design an architecture, also looking on the org structure to which you would map this architecture, because otherwise we will see this conveyor law in practice. Then we have a super cool architecture of, microservices, all this fancy stuff, GenAI and so on. But this architecture cannot be implemented because it's totally ignoring our org structure, not even org structure, but team structure, all our team limitations. I'm not even talking about what kind of experts do you need. Let's assume that you have enough experts, but you need to organize those experts in the proper teams to be successful in delivering one or another use case, because otherwise you will have, again, some kind of isolated silos of data scientists, domain experts, developers, the rest of engineers who will live in their separate worlds. They will never intercommunicate, and again, you will see these unsuccessful pilots because of, somebody don't talk to somebody.
Pretty interesting.
It's not even a problem of building AI. It's a general problem of any kind of solution and software architecture. It is well-known convey law.
Absolutely. And it's super interesting to hear that because our colleagues did a survey last year on AI success, and we found out like two barriers. The first one is data quality that 44% run into. You already said a lot about that. And the second one is actually lack of AI skills and expertise. And since then, I'm wondering, like, what are these skills and this expertise that's missing? Is it really hard technical expertise? And you're suggesting, if I got it right, that there is even if you have the expertise, let's frame it like that, then there is still a lot of broad expertise, broad skills across the teams that needs to be built. Is that right?
Yes, and I would even propose to have some kind of translators in this team, because again, we need in this age of AI, in this age of, let's say, wide systems, we need to find colleagues, we need to find the team players who will be able to translate from another, let's say, from one world to another, for instance, from data science to domain experts and colleagues who will be interested in figuring out the problems and live in this, not try to solve a problem, but live in this sphere of a problem, trying to understand what's the real root cause of this problem and why your customer really need to solve this problem, what's the real pain behind this problem. And for this we need, I don't know, smart architects, really AI architects who are not even a problem solver. They are, let's say, in a good sense, problem mediator, who understand the problem, who, let's say, force this problem, maybe some kind of make it worse in their mind, and try to propose a solution, try to translate, hey guys, we have this problem in a business case. It means for business this and this. It can be implemented with the technical stuff in a such way, and to have such kind of mediators, and to have colleagues who have skills in different spheres, who can be this bridge between your team members.
Talking about skills in different spheres, you mentioned that you are delivering more traditional AI solutions like machine learning, statistics, and so on. We discussed also at the last Data Festival, but also in this podcast, some people said, well, due to the hype and popularity around GenAI, the attention for these traditional methods has completely decreased, but it's wrongly, so that we don't talk about it anymore. What's your take on that? Is that correct? And do you also see like a increasing contribution also of traditional AI to the overall AI success? Or would you say, well, that was pretty stable, we continue to do that, and now Gen AI is adding new capabilities? So I would like to understand how you see the balance between traditional AI and, let's say, Gen AI and newer AI forms.
I would say it's more or less stable, so we are continuing to deliver or trying to solve the same issues we have with the classical AI, and I hope and I believe that generative AI can help to, let's say, to make this better. But currently I see the biggest issue that every time when somebody talks about AI, this person under the AI in the majority of cases understand generative AI and LLMs, which is totally wrong, and it's to some extent prevents classical AI for better distribution, for better usage, because I had a lot of discussions with different colleagues when we are talking about building a model which should be responsible for defect classification on the production line. And I heard a lot of times the question, why cannot we just bring LLM to the, I don't know, it's not even to the shop floor, but to this concrete use case. So it's more about, to some extent, GenAI will help us to make things better, but on another hand, we need to build more awareness about what AI can really do, what's the real differences between AI, generative AI, where one or another can be used, when it's a good decision to use a classical software approach, AI or generative AI. It's becomes a little bit tricky. And yeah, with having this generative AI, we are decreasing this entrance barrier for AI sphere. It means that we have a lot of, let's say, rather generic thoughts, generic minds, which are far away from practical application.
Maybe to close this knowledge gap for at least for our viewers and listeners here, maybe on a high level, could you explain how you differentiate what type of AI for what type of problem or use case? When do you use one and when do you use the other?
For instance, I would say mm, you should differentiate in 3 pillars. First pillar, when you need fast reaction time, when you have a rule based logic, it's better to use classical. It's better to reflect in the direction of classical software solutions. For instance, if you need to analyze a huge amount of data, you need to make some kind of prediction, classification, and it's more or less probabilistic task. It makes sense to reflect in direction of classical ML, classical AI. And for instance, if you need to generate something new, I would not say that you need to generate knowledge, because it's questionable whether GenAI is able to generate new knowledge. When you generate a new content, for instance, if you need to generate new images, again, the problem of data in the industry, we don't have enough data, and sometimes it's a good idea to use generative AI to generate synthetic data. For instance, if you need to generate something, synthetic data, text, images, you need to go in the direction of GenAI, but I would propose and I would expect that in 80% you need to stay in the sphere of classical software architecture and classical machine learning, because it's too sexy to go to GenAI, but it's rather easy to make this mistake and to build rather, I don't know, unstable system.
Maybe looking a little bit into the future as a good ending of this podcast, maybe. You are in this industrial world. Yeah? You mentioned where you are, IoT data, production lines, sensor data, and so on. And I had the pleasure to listen to Jan LeCun recently at a conference in Davos. And he basically explained what he's working on. And he said with this super interesting sentence, he said, the real world is more complex than language. Yeah. What he referred to is that he said, like what you are observing, like sensor data, for example, cannot be well represented in GenAI systems. Yeah, so language-based approaches. And then I think he has this idea of a world model saying, okay, we need models that can handle sensor data, continuous data, messy data, that understand physics. Yeah, so can understand whether something is behaving regarding to the laws of physics, for example. So that's, I think, his idea, what he's working on. And since you are now really in this more industrial world, I really would like to hear your perspective on that. So how are we advancing now AI? What's next? What are you also working on? What are you thinking about?
For instance, currently I'm thinking about use case. Again, example of this defect detection. So some kind of big AI system which will contain a classical AI and generative AI. For instance, classical AI can be used to detect where defect is situated on a concrete product, classify the type of this defect, and for instance, send this defect to upper system. And this upper system contains generative AI under the hood. This upper system analyze the whole documentation for this industrial process, and this system is helping operators to define, to understand the root cause of this defect. For instance, this defect was happened because you used a wrong temperature regime in a previous heating zone. So this is some kind of combination of a system where AI can work, let's say, together with generative AI, where human beings can be involved in this, decision loop. And this combination of AI and human will provide a new knowledge, will provide a new use cases, provide a new, let's say, understanding physics of this process. So I believe in this close collaboration. So I don't believe that AI will replace human beings. I believe that it should be used as some kind of enrichment, as some kind of advancement tool for humans to understand more about world around you, more about, let's say, environments around you. It's maybe new way of feeling. It's additional sense you have, let's say, taste, see, and so on, and maybe it's additional feelings. You have this additional sensor way to understand the world around you through this, let's say, to some extent, self-reflection with the help of generative AI, with the help of these large language models. Yeah, why not? It's more philosophical answer.
But a good ending. But I took away that you also think about the combination.
Definitely. Everything you should be born on this, let's say, on this merge of combination. So when you have different spheres, intersection, and everything new borns on this intersection of already existing old school stuff spheres.
Excellent. We are really looking forward to your presentation at the Data Festival in June in Munich. Maybe you want to give our listeners and viewers here a bit of an outlook, what you will talk about?
Yeah, thanks a lot. Yeah, for introducing my sessions. Yeah, I will be talking about AI UA Act. So in 2026, 2027, all systems which contain AI under the hood should be compatible with AI UA Act. And on the event, I will be talking about how you as an architect should apply, what should you do from the architecture, from the technical perspective with your system in order to be compatible, in order to be aware of AI UA Act. I will share some kind of, let's say, technical hints, maybe templates, to help architects to prepare their systems to work with this AI Act. And I believe it should be rather useful and interesting for architects and for product owners who are more or less involved in building these AI products.
I'm sure it will be. It sounds super interesting.
Yeah.
Thanks so much, Nikita. And thanks, Florian. We are looking forward to seeing you in Munich in June.
Yeah, thanks a lot. Looking forward.
Bye-bye.
Bye.
Bye.